Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSE at YourPedia. So today we will be doing a question from our NPTEL question bank series, and the question is from Discrete Maths, question number 31. You can find the question on page number 65. So it is asking which of the following degree sequence is not graphic for simple graphs. Now in order to solve this question, first you need to understand what is a degree sequence and what is a graphical sequence. So any graph, all the graphs will have a degree sequence. So let's say that this is the graph and the degree for this is element is 2, this is 3, 2 and 3. So the degree sequence for this is 3, 3, 3, 2, 2. You will arrange the degree sequence in descending order. So this is how you represent a degree sequence. Now every graph will have a degree sequence. So all the graphs will have a degree sequence. So this implies all the simple graphs will also have degree sequence, and the degree sequence of simple graphs is called graphical sequence. Now graphical sequence is little different because simple graphs have some properties. You cannot have multiple edges, you cannot it is not like multi-edge or pseudo graphs. You cannot have self loops, you cannot have multiple edges. Simple graphs are quite simple as compared to the pseudo graph. So the degree sequence, or you can say graphical sequence, is very much different for simple graphs. Now in order to solve this, we have a theorem called Havel-Hakimi theorem. It is a theorem and we have some steps to solve. We will be doing some steps in order to solve these degree sequence in order to find that whether it is a graphical sequence or not. So let's start our question. So the first option is 2, 2, 2, 1, 1. Now what we do in this Havel-Hakimi theorem is, we will take the first element. The first element is 2. So we will subtract 1 from the next 2 elements. So we will subtract 1 from the next 2 elements and it will come out to be 1, 1, 1, 1. Now you can move further or you can stop here. Now if a degree sequence is a graphical sequence, what will you have? You will have a combination of zeros and ones, and the condition is number of ones should be even. Now in this, number of ones is even, so you can stop right here, but I will be moving forward in order to show you that in the end it will come all the zeros. If you are able to make all the zeros in the degree sequence, then it will be a graphical sequence. Now the next element is 1. So you will be subtracting 1 from the next 1 element because the element here is 1. So minus 1 from next element, which is 0, 1, 1. Now what you will do is you will rearrange this because degree sequence is always in descending order. Now after that, again the element here is 1, so you will subtract 1 from the next element. So when you subtract 1 from the next element, you will get 2 zeros and there are no ones in this. So if you are able to reach till the point when there are all zeros, then surely it is a graphical sequence. So option A is a graphical sequence. Now we will try for the next option. Next option is 4, 2, 2, 2, 2. Now again, the first element here is 4. So what you will do is you will subtract 1 from the next 4 elements. If you subtract 1 from the next 4 elements, you will get 1, 1, 1, 1. Again, there are even number of zeros. So you, at this point only, you can say that it is a graphical sequence. But if you want to solve further, you can also solve further. So minus 1 from here, you will get 0, 1, 1. And if you rearrange this, you will get 1, 1, 0. And for the next element, again 0, 0. And this shows that it is a graphical sequence. Now the third option is 7, 1, 1. Now the first element is 7, so you will subtract 1 from the next 7 elements, 4, 5, 6 and 7. So you will get 0, 0, 0, 0, 0, 0, 0. So again you got all the zeros and no ones in this. So again this is also a graphical sequence. So for the last option, the D option is 5, 2, 1, 1, 1, 1. Now first element is 5, so you will subtract 1 from the next 5 elements. So if you subtract 1 from the next 5 elements, minus 1, minus 2, 3, 4 and 5, you will get what? 1, 0, 0, 0, 0. Now, you have got combination of 1 and zeros. You can say that this is a graphical sequence or not. Can you tell me that whether it is a graphical sequence or not? No, because you should have combinations of zeros and 1, and the second condition that should be fulfilled is the number of ones should be even, so that when you cancel out all the ones, the final sequence will contain only number of zeros, because if the number of ones are odd, you will not be able to cancel all the ones. So now you can stop here and say that this is not a graphical sequence, or you can move forward and try to solve it further. So the last element is 1, you will subtract 1 from the next one element, and you will get minus 1, 0, 0, 0. Now there is a minus 1 here. It is not a combination of zeros and ones, and it will keep on decreasing because you will be subtracting minus 1, or you can say that there is a minus 1. Now there is no proper step given in the Havel-Hakimi theorem for this type of condition. If this type of condition occurs, then you can surely say that this is not a graphical sequence. So what you will do is, you will take the first element, you will subtract 1 from the let's say that the first element is x, so you will subtract 1 from the next x elements, and then you will arrange those elements again in descending order, and you will keep on doing it until you have found the sequence with number of zeros and number of ones, and if the number of ones in that sequence is odd, then it is not a graphical sequence, and if it is even, then it will be a graphical sequence. And if you want to solve further, you can still go on and keep on subtracting minus 1 from next 1, 1, 1 element if you have gotten to the point of combinations of ones and zeros, and in the end it will reach till the point when you will have only number of zeros in your sequence. So by this way you can prove that whether it is a graphical sequence or graphical sequence or not. So in our question, it is a graphical sequence, it is a graphical sequence, it is a graphical sequence. D is not a graphical sequence. So our option D is the correct answer, because it is asking which of them will not be a graphical sequence. So I hope you like the concept of this question, and I hope you understood the question. So keep watching and keep preparing. Thank you.